geometric sequences have terms that have a constant multiplier or ratio. And to determine the constant ratio or multiplier, you just take a look at the current term and the previous term. So to define what our ratio is, you just grab two of your terms and do your division. So for this first example here, we can grab two consecutive terms. So we grab 12 and 6 and we divide and we get 2. 2 is our ratio. And we can use that and we can compare it with all the others. Now again, we need to have a starting point, and we figure that out by again having several of our terms so we can get going. So here we're given that our first term is A1 is 3, and then our ratio is 2, and we can just multiply our first term by 2 to get our second term. And then 6 times 2 is 12. 12 times 2 is 24. Notice we're actually going up by powers of our ratio. So we have 24 equals 3 times 2 to the third power. So our first term was 3. Our second term is our ratio to our n minus 1. In fact, that is how we find our general form. If we want to find any nth term, we just take our ratio to the n minus 1 power and times it by our first term. And we can do that with any of these other examples. So if we have A1 is -1, and our ratio is -3, we just multiply -3 by each of the terms. So we have -1 times -3 gives us +3, times -3 gives us a -9, times -3 gives us a +27. So in this case, since our first term was 1, or in this case -1, we're going up by powers of 3. Now, we don't always have to go up. Sometimes we wind up going down, because in this case, our ratio, in this last case, our ratio is a decimal. So we're going to get smaller. However, we will never go negative. Because our number is positive, we will always stay positive, but we will always get closer and closer to 0. The larger our n is, we will get closer and closer to 0. Notice we go from 500 to 175 really quick. And then we get smaller, but not nearly as quickly, because 375 to 281 is less than 100. And then here we have around 70 different. So it's going to get to be a smaller drop, but it's still going to continue dropping, and it'll eventually go to 0. So our nth term is an, and we times it by our ratio to the n minus 1 power given our starting term. So let's take a look at a couple of examples. And just as those decimals got really small really quickly, we can also get really big really quickly. Well, we didn't do that really big for those first couple of examples, but we were only going up to our 4th term. So what if we were to jump up to our 8th term, or a 15th, or even the 35th term? So let's take a look at that. So let's say A8 is going to be 3 times 4 to the 8 minus 1, which is 7. So this is 3 times 4 to the 7th power, and 4 to the 7th power is 16,384. So let's write that down real quick. So 3 times 16,384 49,384. 4 to the 7th power is that big. And so we do that multiplication, so we have 49,152. So we go from 3 to 49,000 in just a few terms. A15 is going to be 4 to the 14th power because it's 15 minus 1. And that goes to 3 times 268, 435, 456. Look at that huge number. 268 million. Okay, and that's just in our first 15 terms. So we multiply that by 3 and we get 805,306,368. Now can you imagine doing 99? Even 35 gets to be a huge number when we're taking 4 to the 34th power. So I'm just going to stop this example right here at A15. Now, if we have our first term is 67, we're already starting pretty big, but oops, that should be our ratio, not our difference. Sorry about that. So our ratio is -2 this time. So A8 is 67 times -2. Be careful putting it into your calculator. Some calculators need the parentheses around the -2. So it knows that that negative belongs to that 2. So that'll be -2 to the 7th power. Okay, so that will be 67 times -128. So you should have a negative on this one. And this becomes -8,576. So 67 only goes up to, or down to, -8,500. So it's not as big of a jump, but we also have a much smaller ratio. A15 is going to be 67 times, again, put that -2 in parentheses, and we're taking it to the 14th power, because this time 67 times you should have a positive number for the power. 16,384 should be a positive number this time because we're taking a negative number and multiplying itself by itself an even number of times. So that should be a clue. You have an even exponent, positive. Odd exponent, it's going to be negative if our starter is a negative. Okay, 67 times 16,000 will give us 109,7728. So that, again, now we're jumping up to a huge number. It's over 1 million. And if we did -2 to the 34th power, again, we'd get a very large number. So again, let's pause on this one and take a look at our last example. So we have A1 equals 4. So A8 is 4 times 1.35 to the 7th power. When we do that, we're going to get a lot of decimals in the calculator. So we're going to leave our decimals in the calculator, but I'm only going to write a couple of them down here. And I'm going to write little dots because we don't want to round it, because that may affect our result depending on our situation. If we round it too early, we might not have exactly what we need. So this is going to be about 32. And then we're going to have 6886 and a whole bunch more decimals. So that only went up to 32. So that's not a huge jump. But again, we have a much smaller ratio. We have a decimal on that one. A15, we have 4 times 135 to the 14th power. Should look like a 4. 14th power is 4 times And 1.35 to the 14th power is only 66.784 and a whole bunch of decimals, more decimals. So that's going to give us only 267.136. So it doesn't grow as quickly because it's not as large of a number. We just have a small number here. It's very close to 1, but it still goes up because it is greater than 1. And if we had a number that was less than 1, we'd actually be going down, like we saw in that example on the last slide. A35 would be 4 times 1.34 to the 34th power, 35 to the 34th power, and that would be 4 times 2699, make that look like a 2, another 9.027, so 26,999.027 and a whole bunch more decimals. So that would go up to 107,996.11 and a whole bunch more numbers. So again, we're still getting to be a huge number. We're just going a lot more slowly. So I hope this helps you with geometric sequences. They're going to grow a lot more quickly than arithmetic sequences, but they might also shrink, or they might bounce back and forth across the 0 because you have a negative number, whereas the arithmetics don't really bounce back and forth. I hope this helps you out on the geometric sequences.